So in this section, we're going to talk about different roots and radicals and exponents. In the first question, it asks us, what are all the real cube roots of 125? So the word I'm going to zero in on first is cube. So cube is the same as the number 3. So what this question is really asking is, what number are we multiplying by itself 3 different times, and we say 3 because of the cube, to get 125. So another way of thinking of that is x to the power of 3 is 125. If we were to solve this and get x by itself, to get the x by itself, we would take the cubed root of each side. So as a side note, how do we know to take the cubed root? Well, if we had x squared is equal to 9 and we want to get x by itself, we would take the square root of both sides. We just don't usually write the little 2 on square root because it's implied. And when we do that, the square root and the 2 cancel, and then we get left with the right-hand side of plus or minus 3. Now, the reason why we have plus or minus 3 on the right-hand side is because we don't know if that x is positive or negative because it's being squared. So if it was negative and it was being squared, it would end up being positive 9. And if it was positive being squared, it would also end up being positive 9. Now let's take that same concept over to the left-hand side. If we have x cubed, we want to get rid of that x cubed, so we end up canceling here and we get x. So then we're saying what number multiplied by itself is multiplied by itself 3 times is equal to 125. Well, it's 5 times 5 times 5. Now there's many different ways to think about this. 5 times 5 times 5 is the same as 5 cubed. Now what do you notice here? Well, we have that cubed root on the outside and the cube on the inside, so those two are going to cancel. So our end result is just positive 5. Now our question says find the real cube root of negative 125. So again, we have that cube. So what times itself 3 different times is going to equal negative 125? Well, that's the same as x cubed is equal to negative 125. So how are we going to solve for that? To get rid of the x cubed on the left-hand side, we're going to take the cubed root of both sides. That will cancel. And we're left with x is equal to the cubed root of negative 125. So what number, or how can we break down negative 125? Well, that's the same as negative 5 times negative 5 times negative 5. We change this to be negative 5 cubed. And then that cubed root on the outside cancels with the cube on the inside. So we're left with x is equal to negative 5. Do you need to show all these steps? Nope. I'm showing all of these steps because I want you to understand why this is the case. But really, your solution could just be the cubed root of negative 125 is equal to negative 5. What is the meaning of the exponent in the expression 16 to the exponent 1/4? So this is interesting wording. It says, what is the meaning of the exponent? So we're going to show how this exponent actually relates to a radical or a root. The first thing I want to do is break down 16 to the 1/4. So the one thing I want you to see is that 16 we can actually rewrite 16 as 2 to the 4th, and then I'll take that exponent of 1 to the 4th and just carry it on the outside. So the 16 has become 2 to the 4th because 2 times 2 is equal to 4. 4 times 2 is equal to 8. And 8 times 2 is equal to 16. So 2 to the 4th is the same as 16. Now, back over to the left-hand side. If you think back to your exponent laws, when we have an exponent raised to another exponent, that's the same as just multiplying them together, if we're going to simplify. So when we simplify this, we end up getting 2 raised to the exponent 1. So therefore, if we go back to the original question, 16 to the 1/4 is actually equivalent to 2. Now let me show you this, a similar question. If I gave you the 4th root of 16 and asked you to simplify that, well, we already proved that 16 is equivalent to 2 to the 4th. So I'm going to change the 16 to be 2 to the 4th. And then just like the problems before, when we have a 4th root and a 4, we can simplify that and it will equal 2. So what is this really telling us? If we go back to the original question, because remember it's asking for the meaning. If we've now proved that 16 to the 1/4 is equal to 2, and we've also proved that the 4th root of 16 is also 2, then that means that there has to be some relationship between the exponent of 1/4 and the 4th root. So here's our relationship. In general, for positive integers n, where x is raised to the 1/n, is defined to be the nth root of x. So that means that if we have a base of x, and on the left-hand side, the denominator of the fraction of the exponent is n, then that denominator will always match the nth root, so whatever the root is. So for example, if we have x to the 1/3, that's going to be the third root of x. If we have x to the 1/5, that's going to be the 5th root of x. So the bases are the same, so the base on the left-hand side is equivalent to the number underneath the radical. The denominator on the left-hand side is the nth root on the right-hand side. So here's another question. It's a little bit more tricky because we also have a numerator. Well, we're first going to identify the fact that we have that 27. So we're going to put the 27 underneath. And then we have the denominator is a 3. So we're going to put that on the outside. Now, what are we going to do with the 2? The 2 is actually the power of the entire thing. And then we use our order of operations. So we're going to simplify the inside. So we're going to take the cube root of 27. 27 is the same as 3 times 3 times 3. So really, we have 3 cubed. We will cancel. So we end up with 3 squared, which is equivalent to 9. So here is the rule written out for you. If we have the nth root of c, that's equivalent to c to 1/n. If we actually have something in the numerator, that becomes the power on the outside. So you might want to pause and write this down. Evaluate the expression with rational exponents. So we're going to rewrite this. We have 32. The 5 in the denominator means that we're going to take the 5th root And the 3 in the numerator means that we're going to cube it afterwards. So we're looking for a number that when we multiply it by itself 5 times, it ends up being 32, which is 2 to the 5th. So the 5th root and the 5 cancel, so we'll end up with 2 cubed, which is the same as 8. The next one, 27 to the negative 2 over 3. So we're going to start with the 3, so that's the cubed root of 27, and then I'm going to raise that to the exponent of negative 2. We can't have a negative on our radical. So we're looking for 27, is the same as 3 cubed. Then we take the 3rd root of that. So we end up getting 3 because the 3rd root and the power of 3 cancel. We're left with just the 3 underneath, which is raised to the negative 2. A negative exponent means that we take the reciprocal. So 3 becomes 1/3, and then it's raised to the positive 2. So this ends up being 1 over 9. The last question, we're looking for the 4th root, the 4th root of 50 cubed. So we're looking for a number that's multiplied by itself 4 times, that are going to give us, 4 times, so we can cancel out that 4th. But if we think of if we think of 50, 50 is 5 times 10, which is 5 times 2. So none of these factors, we don't have a factor that we are actually able to raise to the exponent 4 in order to cancel out the 4th root. So this one, we're going to have to use a calculator. And when we do, we get approximately 18.8. Our last question, we're actually going to put a variable in here too. So we can separate it and look at 32. We want to change this to have a power of 2. So it's going to be 2 to the 5th. So we're taking that 5th root. And then we also have to take the 5th root of m to the 15th. But in order to cancel this, we need to rearrange this to be a 5th root. So the question is what are we going to put on the m? So remember that if we want m to the 15 and we have a 5 already on the outside, we're going to need a 3 on the inside, because the rule is that we multiply these questions together, those numbers together. So I'm going to rearrange this, and in order to have a 5 on the outside, that exponent of 5, and we want this because it has to cancel with this one, then we need m cubed underneath, because that 3 times 5 is equal to 15, which is in our original question. We can cancel the 5th root and the 5. That's going to give us 2. We cancel the 5th root and the 5, and that's going to give us m cubed. And that's our final answer.